is we look at, remember, we look at this quantity, right? And we've been focused on this quantity like the whole semester, and we did the quantity demanded, the quantity supply, then we did all the things that would impact the demand curve, you know, like elasticities, right? We said price elasticity, that's how much price impacts the demand curve, and then cross-price elasticity and income elasticities. And so we calculated everything like looking at that Q, and how is Q affected on the demand side? Well, cost looks at Q from the supply side. So that all of the costs are looking at, they're going to look at what changes the supply curve. So when the costs go up, supply curve will shift to the left. When costs go down, supply curve shifts to the right. But we're not really looking at supply curves now, we're looking at cost curves. And believe it or not, they're basically the same thing. So when you look at this, and we're saying right now, this Q is a function of, or is dependent on, so Q is your output, and your Q as output is dependent on your inputs. And your inputs are simply capital and labor, and each one of these will have a cost, right? So there's a cost to capital and a cost for labor. So the output is a function of the input. So the whole point of what we're doing here is to look at these and how much these cost. I mean, how much do these inputs cost? And then not only that, but once we figure out what they cost, then we have to we're going to end up with these lines, these curves. And the reason I put these images up here is not to dazzle you with, you know, how cool economics is, because I know you're thinking that. But but to look at each one of these, and I'm going to come up with the same exact thing, all right? Same exact graph, same exact lines. And my point is that this is the same as this, and this, and this, and this. They're all the same. All right? So what we're going to do is we're going to end up at the same place that everybody else who's done economics ends up. And so we're going through this process of we're coming up with these lines. And the lines are going to be the same as every other econ student, whether you're at York Tech or Harvard, they're going to come up with the same exact lines. So we're just going to look at these and say, where do these lines come from? And then once we have these lines, then we're going to use them. So we're not going to look at the numbers anymore or where they came from. We're just going to use these lines and say, all right, well, this is, what is this? Well, this is an average total cost curve. An average cost, we've already talked about average cost in here. But that's what they're going to look like, that little faint yellow thing, or this one here. It's the same thing. And this here is called the marginal cost curve. And this is an average variable cost curve, and that's an average fixed cost curve. And they're always going to be the same. Every time you do these, you know, these graphs, they're always going to be the same. So just like if I said to you, draw a demand curve, right? We would go, okay, well, here's the demand curve. It looks like that, right? But so you don't think about where the numbers came from anymore that are behind this demand curve. You just draw a demand curve. And the same thing is going to be true with an average total cost curve. I'm going to say, okay, draw an average total cost curve. You know, it looks like that. You're not going to, you know, today we're going to look at the numbers behind it and where this thing comes from. But after that, it's just going to be, okay, here's your average total cost curve. That's it. So you're not going to have to, you know, come up with the numbers. Just like demand curve, you know what it is, you know why it is. It's going to be that way for the cost curves after today. So that's my point of today. I mean, cost. And so we're going to look at this and we're going to solve for the formulas. So you start with the front page of this, oops, I don't know where this one is. There's a cost assignment, it says. Right? So if you have that page and you know it's cost assignment, and we're going to just kind of go through that. So let's take a look. So right here, marker, and okay, so let's look at the definitions first. All right, we have this this cost, and the cost is going to be determined by how much these inputs are that it takes to put the product out there. You know, we can say, all right, there's a demand for this chicken sandwich. How much does it cost to get it there? Well, they have to have the people cooking it. They have to have the ingredients. They have to have all of the kitchen equipment. They have to have all that capital. So there's all this cost that goes into it, and then from there, you know, that's where the chicken sandwich comes from. So there's all this cost. So let's look at the cost. All right, so start with, you have total cost is equal to total fixed cost plus total variable cost. Okay, so the total fixed cost, so fixed costs are just costs that don't go away. So no matter what happens, you still have these costs there. Even if your company shuts down, you still have the cost. And that's what's meant by being fixed. So when you have like when I used to own, I owned a little store, and when I went out of business in like March. But I had to pay rent until September. So my rent was a fixed cost. Even though I was not producing anything from March to September, I still had to pay the rent. So rent would be fixed. It's a cost that I can't get rid of even though I shut down. And so that's cost. So these fixed costs are costs that are going to be incurred even when your company shuts down. Variable costs are going to change. So total fixed costs, let me write this out. They're on the sheet, that's why I didn't write it. But in total variable costs are costs that are going to change with output. So these will change with output. In other words, if you produce more, then your variable costs are going to go up. So if I mow one lawn a day, then I need say I can have one person doing that job. If I mow 50 lawns a day, I have to have more people doing the lawn mowing. So I have to hire those people. So my cost for those people will be variable. So that's a really easy example, right? Because I can't mow the lawns unless I have people to mow the lawn. So, but if I don't mow the lawns, then I don't need the people. So the variable cost means I'm going to have more people mowing the lawns when I mow more lawns. Okay? So if my output is higher, then my variable costs are going to be higher. If I don't have anybody working, like I'm building a house right now, all right? And every time it rains, they take the day off. Okay? I love it. It's great. Okay? It's because we don't have a roof. Okay, so all the water comes pouring in. So that's a variable cost. We don't pay them for days that they're not working. But when they start working, we pay them. Okay, so the fixed costs are costs that you have to have, or you have to incur, and the variable costs aren't. So I'm going to put these like, let's not do this anymore. Let's just take these and put them over here. Because every time. Okay, so if you need extra stuff, anybody comes in, send them this way. Okay? Because I am not tall enough to see over anybody. Okay? So thank you, okay, so that's the total cost would be you add this up and this up. So take a look at your sheet there. All right, and you have, now I move my sheet. Okay, but if you look at your sheet, and it says the cost assignment, then looking at some of the things you have total cost. So I'm going to go over from here. It says total cost, and then the next row over somewhere that says total fixed cost. And then it says total variable cost. So let's take a look at those first. It says the total cost, when I'm producing here, this is my quantity. So here are all the things that I was talking about here. We have the quantity is going to help be a function or determine these costs, right? When I need to know my quantity to know my costs. I need to know my quantity so I can know what inputs I need to put that good out there. So my quantity is 0, my costs are 8. So what does that tell me right there? How much would be my fixed cost? 8. Now how do I know that?
producing anything.
Right, even though I'm not producing anything, I still have cost. So that means that cost is fixed. There's nothing I can do about it. Right? So that gives me my answer. Now, if it's a fixed cost, guess what's going to happen to it in the future? What do you think the fixed cost is going to be when I produce 2 or 3 or 4 or more than that? What's it going to be? 8. It doesn't change. So I can just write 8 in all the way down. When I produce 1, when I produce 2, when I produce 3, it doesn't matter. All the way down, and just write these numbers here. When I produce any of these amounts, my fixed cost is still going to be 8. 26, 34, 44, 56, 70, 85, and 100. Okay, so the fixed costs are fixed. They're not changing. So that goes down all the way down. You fill in that column. Okay, so what's left? This is, we know the formula here, so what do you think the variable cost would be here, for instance? 0. There are no costs. Remember, this equals this plus this. So total cost is 8, then my variable cost has to be 0, which makes sense because I'm not producing anything, so I don't need any labor to produce nothing. If I'm not producing anything, I don't have the variable costs. Those are all gone away. Only costs that are left are my fixed costs. But when I produce that first unit, what's my variable cost going to be? 7. And then when I produce 2 units, what would my variable cost be? 12. And if you're not like following this, just ask the person next to you. Okay? Hopefully you get it together. Okay, 26 and is the third. So next one would be one more time? 18. Okay. So that's the variable cost. So you kind of get the picture, right? And what will happen to variable cost is it's going to just make this trend upward. Okay, so it's going to go up. The fixed costs are going to just be consistent. So if we go back over here and we say, all right, what would that look like on a graph? So let's take the total fixed cost here, the total variable cost here, and the total cost here, and then take the quantity here. So I'm going to take a look and say, what would be the average the total fixed cost? What type of line would that look like? Well, if I produce 0, how much are my fixed costs? If I produce 0, how much are my fixed costs? 8, right? If I produce 1, how much are my fixed costs?
7.
My fixed costs? 8. 2, 8, 3, 8, 4, 8. Got it? So it's just, all it is the line with a straight line. That's my fixed cost. Good enough? All right, so we're done with that one. Now, let's go a step further with this and say, all right, what about the average cost? And in a lot of books, you'll see average cost. You'll see ATC, but ATC is average total cost. AC is average total cost. They're the same thing. Okay, it doesn't matter. I always have AC, but a lot of people, a lot of books will say ATC. But I'm just saying average cost. The average cost for this good is. So the average cost is equal to your average fixed cost plus your average variable cost. And your average fixed cost is just your total fixed cost. So it's TFC divided by Q. Your average variable cost is TVC divided by Q. And your average cost is your TC divided by Q. So we just take this whole equation, multiply it by, or divide it by Q, and then we have those other terms, average fixed cost and average variable cost. So now let's just figure out the average fixed cost, since we're focusing on that right now. The average fixed cost is just your total fixed cost divided by Q. since you can't divide anything by 0, it's undefined. So 8 divided by 0 is undefined. What about 8 divided by 1 would be 8. Then 8 divided by 2 would be 4. And 8 divided by 3 is what, 2.66 or something? 2.67. And 8 divided by 4 is 2. And 8 divided by 5, 1.67. 1.67-ish. And et cetera, et cetera. So what's happening with this here? What's happening with those numbers? They're going down. So all that means is I'm dividing that fixed cost by more and more of a quantity. So your fixed costs are dropping when your quantity is increasing. And it's as simple as saying like this, okay? Let's say they pay me, well they don't, but let's just say they pay me $40,000 to teach this class, all right? And there's 40 people in here, okay? So let's just say that's what they have to pay me. They have a contract, they have to pay me that. So there's 40 people in here. That would mean that each one of you contributes $1,000 to my salary, okay? What would happen if we just increase, so we'll call that the average fixed cost, right? You all have to pay that, it's fixed, okay? What would happen if we let in, if I went and did this in a big hall, like they do in, some universities, and there were 200 people in here, then what would happen? What happens when the quantity goes up? What happens to the per unit cost? It's going to decrease. So this is going to be, what's that, 200, right? And so what goes on here is as you increase your output, assuming your costs are constant, then you're just going to have a decrease in this line. So the line's going to basically look like this, right? It's at 1, it's here, and it's like here, and it just kind of goes like that. That's what the average fixed cost line looks like. And you're not going to see that very much, and just have to show it to show you that costs are going to be decreasing as the quantity increases. Okay, that's the whole point. So far, so good. I'm trying to go as fast as I can, because this is about as dry a topic as there is. The costs aren't necessarily like the sexiest thing in economics. Okay, so not as cool as some of the other things. Okay? So but is everybody all right with these two? So your average fixed cost will look like that. Your average variable cost, or total variable cost, looks like that. Okay, good so far. Okay, let's look at this total variable cost, and we'll kind of isolate that. So we'll take this here, and we'll put it on another graph just for keep us focused. And the total variable cost, let's fill in this column here, and the column is like from, what would be the rest of these numbers here going down for total variable cost? Does anybody fill that in yet?
Yeah.
What is it? After 18, it's 26. Yep. Keep going, please. 36. 48.
77, 92.
Okay, 77, 92. I missed the last one. 762. 77, and 92. Okay, so what's going on with these numbers? What are they doing? They're just going up. So we start with 0, and then I'm just going to plot them. So at a quantity of 1, we have actually at a quantity of 1 we have 7, and a quantity of 2 we have 12, and a quantity of 3 we have 18, and it kind of just looks like this, right? And then it kind of goes like that. That's what the total variable cost line looks like. So it just keeps going up, and it gets going up at a faster and faster rate. So it starts off going kind of up slowly, and then it just takes off. Okay. Now let's do the average variable cost. Average can't do so it's going to be the total variable cost over Q. So when you take the total variable cost, you take this number here and you divide it by the quantity. So the total variable cost of the first unit you can't do because there's a 0 in the denominator, so you can't do that. But then the 7 divided by the 1 will give you a 7. And then the 12 divided by 2 gives you 6. And 18 divided by 3 is 6. You guys see where I'm getting these numbers from? Yes or no?
No, wait,
Okay. I'm going with TV's, this column here and this column here. So 7 divided by 1, 12 divided by 2, 18 divided by 3, 26 divided by 4, etc. Okay, so 26 divided by 4 would be like 6.25 or 6.5. And then 36 divided by 5,
7.2.
7.2. Keep me going here since you're on a roll.
Okay, all right.
Oh, you were on a roll. Okay, the 48 divided by 6 is 8, yep. And then what? 62 divided by 7 is
8.8.
Thank you. And one more, two more.
9.6.
9.6, and it's your total fixed cost plus your total variable cost. So these two numbers added up are going to give you this. So if you want to draw in your total cost curve, we'll use this graph here because we're already kind of started on it. And your total cost curve is going to be this line, the total variable cost, plus this line. So basically it's this line plus 8 in this example. And so if you look at here's the total variable cost curve, right? If you added 8 to it, we would be on this line right here. So all I have to do is just take this here and push it up by 8. So it kind of looks like this. And that would be the total cost curve. And we're looking for the total variable cost, and we put it on the same graph, it would look like that. So what's the difference between here and here?
Plus 8.
8. Everywhere you go. If you go from here to here, it's 8. Here to here, the difference is 8. Here to here, the difference is 8. Right? Here to here, the difference is 8. So there's always a difference of 8 because the difference between the, in our example, right? If fixed costs were 50, then the difference would be 50. But in our example, the fixed costs are 8, so the difference between here and here is always going to be 8. The difference between here and here is the total fixed cost. All right, so now, the ones that matter the most to you, or are going to matter the most about for the rest of the semester, are the next two columns. So I'm going to put those separate. Okay, so these are cool, all right? You'll see this like once or twice. This average fixed cost, you're not going to see very much. Average variable cost will come in one more time. The only other time we're talking about it is when with a shutdown decision with perfect competition, which we'll talk about in like 2 weeks, 3 weeks. Okay? So, but the ones that matter the most to us are the next two. Okay, so let me just set the stage here. So the ones that we follow the most are this column here and a marginal cost column. So MC is the marginal cost. And it's the cost of producing the next unit. It's the cost of producing the next unit. So formula-wise, its marginal cost is just your change in total cost over your change in quantity. It's your change in your total cost over your change in your quantity. So you take so we have our total costs are here. I'm going to put it, I can put it right here, make it easier. Right? So I'll put it right there. So your change in your total cost is how much? Well, it went from 8 to 15. So that is change of how much? So let's do this one together, okay? We're looking at the marginal cost now. The marginal cost is just your cost difference from how much will it cost to make the next unit. So if I'm going to make my next, chair here, right? I'm going to make the next one like this, okay? How much will it cost to make this? How much will it cost to make just this one? Okay, and all right, well, when I produce 0, my costs were 8. Now I'm producing 1, and my cost is 15. So how much did it cost to make this? 7. Does everybody see that? Because marginal cost is a really important concept. It's one for the rest of the semester. You're going to hear about this thing called marginal cost. And it just means the cost of the next one. Does everybody see that? Yes or no?
Yes.
Right? Are we good? Because I don't want to move forward until we get this. How much does the next one cost? Because you see, that tells me whether or not I should sell the next one. I mean, I just said this next one costs $7, right? What if the price of this is $6? Should I even make this? No. But what if the price of this is $25? Should I make it?
Yes.
Right, because how much am I going to make when I sell the next one? I'm going to make the difference between the price and the marginal cost. So it's important for us to know how much this costs because it helps us determine whether or not there should be an exchange made. And from a business perspective, that's the most important question that they can look at, is whether or not they should make an exchange. And so in this case, the marginal cost is going to be 7. What about the next one? How much does that cost? 5. Awesome. And the next one? 6. And the next one? 8. And 10, 12, 14, 15, and 15. All right, now let's fill in this average cost column too. So the average cost is just it's going to be your total cost divided by Q. So it's this column here and this column here, divided them. Now we're just dividing them. So 8 divided by 0, we can't do. 15 divided by 1 is 15. 20 divided by 2 is 10. And 26 divided by 3, 0.6x. 34 divided by 4, 8.5. And 44 divided by 5, 8.8. So now it's starting to go back up. You can see it was high, it got really low. This is the minimum point here, right, where it went to 8.5. That's the lowest it went, and now it's going to come back up. So what's the next one is 56 divided by 6, 9.3. And 70 divided by 7 is 10. And 85 divided by 8. Okay, awesome. And then 100 divided by 9. So what happened with this is it went down and it slowly went back up. What happened with this is it went down sharp and then went back up quickly. Just looking at those numbers here. Okay? So now what does that look like on a graph? Again, these are the graphs that you're going to, these two here, the marginal cost and the average cost, are the ones you're going to have to know for the rest of the semester. So I can fly through these and just kind of introduce them to you and give you a couple facts about them and we can move on. But these next two, you're going to have to know. So your marginal cost line will look like, we'll plot it out. And we take your marginal cost here and your average cost there. And your marginal cost at 1, so we're going to go 1 through, let's say, 7. We won't have to do, we won't do all of them. And then on this line, we'll just go, we'll put like intervals of 5, like 5 and 10 and 15. So We'll try to be as accurate as possible, but we'll just do that. So here's our quantities here. Here's our marginal cost and average cost, and we'll go one at a time. So let's start with the average cost. When the quantity is equal to 1, our average cost is 15. So that'll be right here. And when the quantity is equal to 1, our marginal cost will be 7. I'll do that in blue, and I'll do this in... Okay, so everybody see that so far? So the average cost, when the quantity is equal to 1, the average cost is 15. When the quantity is equal to 1, the marginal cost is 7. Is that cool? So we start off with the marginal being way below the average. Okay? The next one. The marginal, or the average cost now drops down to 10. So at 2, we're at 10. And at 2, what's the marginal cost? 5. So marginal, they're both falling right now. Okay, when the average is falling, all right, and the marginal is falling at the same time. So the marginal falls first, and then the average follows that. The third one would be 8.66. So that would be about, let's just say about right here. And what's my third one for marginal cost? Yeah, it's right here, it's 6. Okay, it's what's the marginal cost when the quantity is equal to 3, and the answer will be 6. So it's a little bit higher than that 5 number, so we're starting to come up a little bit. How about at 4? Well, at 4, we're at 8.5, so about the same place for average cost, slightly below it. And marginal cost is now 8. With me? Okay, so the marginal now is 8, so it's slightly below that. And I know I'm going slow here, point by point, and in real life, like I said, what I'm trying to do here is I'm trying to show you where these lines come from. And then after that, then I'm not going to have to do it anymore. Just like I don't have to go over the demand curve anymore. I don't have to say, here's why it's downward sloping. I don't have to do a demand schedule and say, when the price is high, and the quantity demand is low. I don't have to do it and talk about the law of demand anymore. You already know it. That's how it's going to be after we do this. Okay, so that's my rationale for taking my time doing this. Okay, then the next one at 5, let's do, at 5 we're at 8.8. So we're a little bit, we're back basically a little bit above this point right there. So it's about right there. And what's the marginal cost now? At 5, what's the marginal cost? 10. So that's going to put me right back here. So what happened? What happened there? The marginal cost went above the average cost. Right, I'll do one more point. At 6, what's the average cost? 9.3. So it's a little bit higher than that 8.8, so we're like over here. So you can see this curve now. Let's draw that line, connect those dots. And that becomes our average cost curve. Okay? And then if you go to the marginal cost for the next number, which was 6, the marginal cost at 6 is 12. So we're pretty high up now. We're like up here. Okay, so now I'm going to connect those dots, and it looks like this. And I'm not really drawn to scale, but it's pretty good. Okay? So that's what you're going to need to know. Okay, that's where these times come from. So now I just want to, now that you know that, Now, and you see where they come from. Now, every time I draw an average cost curve, I'm going to go, okay, here's your average cost curve. Why? Because this is where I got it from, okay? That's what they look like. And every time I draw a marginal cost curve, I'm going to say the marginal cost curve starts below the average, swoops up, and goes like that. So you're always going to get, your graphs are always going to look like this between the two goods. I mean, the two measures. Okay? Does that make sense to you guys? You know, I know we're not using it yet. All we're doing is really just looking at the two in relationship. Okay. Any questions yet? All right, so let's take a look at the ones that I have at the beginning of the class. I was showing you that what do they look like? You know, where does the rest of the world think of these whole cost curves? And here's what happens, right? We have this is, and the bubbles just add a nice effect. I'll leave them there. Okay, so, but here's what you know, the line that we just drew, right? Average fixed goes down, average variable the marginal goes down and swoops up through, and here's your average cost curve. See, everybody's drawing in the same way, right? No matter who's drawing the graphs, this is the same thing I just did. It's a little bit neater and a little bit more color coordinated, but it's the same thing. No matter where you look, they're always going to be the same thing. Here's your average variable, here's your marginal cost that swoops through. Here's your average variable, here's your marginal that swoops through. Now what happens is this average and average variable will get closer together. So there's about 5 points now I want to talk to you about that are going to be like things you always have to remember about these cost curves. Here's the 5 important points. Number 1, as quantity gets bigger, as the quantity gets higher, see, in other words, as we go this direction here, your average fixed costs are going to get lower and lower. Okay, all these are on my notes too, but I just want to show you visually. So as the quantity increases, the average fixed cost gets closer and closer to Q. That's number 1. Okay? In other words, we're dividing those fixed costs by more and more units. Number 2, as the quantity gets bigger, because the difference between the average fixed and the average variable, in other words, if I took the average fixed cost, or average total cost, minus the average variable cost, I get the average fixed cost. So so that means the difference between these two lines is going to be your average fixed cost. So the difference between this line and this line is your average fixed cost. But since the average fixed cost is getting closer to 0, then the average variable cost and the average cost curve get closer together. In other words, as quantity goes up, this number becomes 0, so those two become more equal. Okay, that's number 2. It doesn't mean that much. I'm just saying that's graph-wise. It's important to know when you're drawing. Okay, number 3. Right. The marginal cost curve will always intersect at the minimum point of the average variable and the average cost curve. When the marginal comes through, it always intersects the minimum point. Okay?
The minimum point of what?
Minimum point of the average cost curve and the minimum point of the average variable cost curve. So whenever you're drawing your picture, like I drew it here, I would say I'm drawing my picture here, I got my average cost curve looks like that. Right? If I'm drawing my average cost curve like this, then I go to the minimum point, which is right there. And I draw my marginal cost curve, swoops through there. Always goes through there. Okay? So that's, and then the next one is probably the most important. And then hopefully I can move on a little bit. Okay, so the next one is this, right? When the average, the relationship between the marginal and the average cost curve is what I'm talking about, okay? When when the marginal is below the average, then the average falls. And when the marginal is above the average rises. Okay, so I'm going to give you a visual of how this can happen. Okay, so what do you think the average height in this class is? You have to guess. What do you think?
36.
I mean, probably let's just say the average in here is probably 5'6" or so, 5'7". 5. A lot of girls in here. Okay. All right. So let's say the average is 5. Let's just say 5'5". And then I walk in. What just happened to the average?
It went down.
This is for a grade now. Okay. So be polite. So what just happened to the average? I'm the marginal, right? Right? You have the average. Now I step in. What happens to the average? Well, I wish. But, all right, but it went down because I'm 5'4", okay, and a half, 3/4. All right, maybe 5'3". But anyway, see so I'm the marginal. When I walk in, what happens? The average drops because there's something below the average. It's if you have really hot water in a bathtub and you add colder water to it, it brings the average down. Okay? If we walk through the door, and if somebody walks through the door that's, on the basketball team here at Winthrop, the average is going to go up. Okay? So, do you understand the average, when the marginal will change the average? So, at this side, when we look on this side of it, the marginal is below the average. So the marginal brings the average down. So that when the marginal is below the average is falling. When the marginal is below the average is falling. When the marginal is above the average is rising. And that's the even point. At this point, it would be like saying if I'm 5'5" and I walk through the door, I'm the same as the average, so what happens to the average? Nothing. Right, because I'm the same as the average. Okay? So that hopefully kind of explains some of those different relationships for the averages. Okay? Any questions so far? Because I'm going to give you like a little cost puzzle here in a second and see if you guys can figure it out. Okay, but does anybody have any questions about the cost curves? It's more important than anything, guys. It's just a lot of memorizing formulas. Formulas aren't hard. You're dividing. That's about it. You're just dividing numbers by numbers, and that's about it. So there's not a lot to the formulas, but you have to know. Okay, so I was looking for my notes. See if I have them. Okay. Yes.
What's the formula for TBC then?
It's just the TBC is going to be basically it's going to be given to you, but the only thing that you have for TBC is TC equals TFC plus TBC. So if you want to go TC minus TFC, you get TBC. Okay, so you just subtract the fixed cost from the total cost and you get the variable cost. Yes?
Did we go over MR?
MR, well, we didn't, but I don't need to yet, because that's just marginal revenue. But that's not that won't be for a little while.
Are you still,
Question, keep going.
are you still going to write the formulas on the board for the test?
Am I gonna for the test?
Yeah.
I'll write some of them. I don't know, you know what, but again, it's kind of like elasticity. If I said, what's the elasticity formula? I mean, how many of you guys could write it down right now? You know what it is. Just raise your hand if you don't, I'm not gonna make you do it, but how many of you guys are pretty comfortable with the elasticity formula? Really? That's all? After 65 examples of it? I mean, so most of you guys, okay, how about this? elasticity, EP is equal to, how about that? Change in, over
Average quantity.
average quantity. All right, times average price over change in price. See? So I'm thinking if I write down the board, you guys are cool with it, but most of you guys will just look at it for like a quarter of a second. And that's how it's going to be with these cost formulas too. But I don't mind. It's not. I don't mind writing a few formulas on the board. But that's not going to. You know, I'll give you an example right here. Okay, all the formulas will be up here, and here's the total cost. Okay, let's do a little thing. Okay, Q, TC, MC, total cost, total variable, average fixed, average cost. I think that's about all of them, right? But these are all the ones that we went over, I think, so far, right? Okay, so let's say 0, 1, 2, and I'm gonna give you like a little. Who does those number game things? Sudoku, what do they call Sudoku? What is it? Sudoku. Who made that name up? But that's what this is gonna be, like this little Sudoku game. So we'll take this and go. All right, this is. That makes sense? No, yeah. Nice. All right. I think I can get that. Okay, can you fill in the rest of the table? That's your challenge. Okay, so what do I have to do? Bribe you? Right, so let's so we have to fill in this whole table, yes.
Is that 70 in
This is,
quantity 2?
oops, yeah, I didn't, that would be my supposedly straight lines. And knowing the formulas, TC equals TFC plus TDC. Well, MC is the change in TC over the change in Q. And then average cost equals average fixed cost plus average variable cost. Average cost equals TC divided by Q. Average fixed. So you have all the formulas. Stop. Okay. Where'd you get that from?
90 minus 60.
See that one? No swearing. Okay. So it's good, right? Because the marginal cost is 60. So he's going from here to here and saying the difference between these two is 60. We know that. So if the difference between these two is 60, then that has to be 30. Okay, keep going then. And where did you get that from? That's an easy one, actually. I'm sure a lot of you guys like that. But where did you get that from?
Okay.
Yeah.
That was the change in total cost.
No.
I worked, that was the last thing I got.
Oh, really?
Yeah.
Okay. How would you come up with that, you guys?
70 divided by 2.
Yeah, 70 divided by 2. Because your average cost is, remember your total cost divided by Q is equal to your average cost. And this equals 2. This is total cost. And this is equal to 70. So what divided by 2 is going to give you 70? Or more, 140. And then you got it from there. Keep going, real quick. Okay, so we can't do the marginals, can't do, there you go. Good. No. What would be the difference between those two? 50, right? The marginal cost one? Huh?
I divide it.
Okay, yeah, it's just the same, it's just the,
90 minus 140.
yeah, it's just 90 minus 140. All right. 30, 30, 30. You see where the fixed cost came from? Yeah? If the fixed cost is, but yeah, you had 90 because you didn't have the first one, right? And yeah, you're doing well, keep moving. Yep, good. Good. All right. Looks good to you guys? All right. Well, thank you. Thank you very much. Good job. All right. We will add quiz points or test points? Test points. Test points. Okay. Okay, so look at this now. All right, going from here to here is 60. So that's how we came up with the marginal cost. And then dividing, if the average cost for 2 units is 70, then that must mean the total cost is 140. Once you have that, now you can fill in that fixed cost one, because when costs are 30 and you haven't produced anything, that must mean that all those costs, the $30 is fixed, because you can't get rid of it. Right? When the quantity is equal to 0 and you still have a cost, then that means you have no choice, right? You have to pay it, so it's fixed. So it's fixed means it's fixed. And then the variable is just the difference between here and here. So 90 minus 30, 140 minus 30. So that's good. Averages are just divided, right? That's just a blank. And these look good. 90, this divided by 1, this divided by 2 is good. So everything else is good. Okay. Any questions? So that's yes.
Okay, so I guess I'm confused on like how it work. I want to set it backwards to the 0.
Backwards to
I
this.
can get the 1 too, but I don't understand.
This one?
Like the whole 0 line.
Because once you had this, right? Once you had got the 30, then when your quantity is 0 and you still have 30 units, $30 of costs, then it must mean that your costs are fixed.
Okay.
And everything else is just blanked anyway, except for variable costs. And then once you know that the 30 is all fixed, it has to be 0. And then everything else, like I said, is undefined. Okay. Other questions? All right, so good. Okay, we're gonna just, I'm just gonna start productivity, and then we'll take it, we'll finish it. We'll do a lot on it next time, but I just want to make sure I go a little bit quicker, or not too quick, but I just want to make sure I introduce stuff, because I want to have more time to practice the problems. So I'm going to introduce some of the different concepts of productivity now. And all productivity is it's going to end up, being productive means that, you work harder, right? Or you end up with, with more product per hour, than you did before, right? So it's your productivity is just how much output you have divided by the labor. That's going to be your average productivity. So we just take your output divided by your labor units, and that gives you something called average product of labor. So if you were to look like nationally right now, we do this in manufacturing a lot, and you say the total number of, if you look at the total number of dollar units of per manufacturing person, right? And so you take how much do we produce in this country in terms of cars and refrigerators and all that stuff? You add up all our manufacturing and you divide it by the number of workers, it's pretty astounding. It's like about each worker in manufacturing produces about $150,000 worth of goods a year. So it's pretty amazing, but they only get paid about $60,000 per year. So there's this big disconnect between what they're producing and what they're getting paid. And really the whole point of productivity, and this is called the average product of labor, okay, is because this productivity helps to determine our wage rate. So you look at what each person adds to the production function. So here's how it's done. Okay, we have this output is a function of these two inputs. So the inputs are capital and labor. So K is capital and L is labor. And of course each of these has a cost associated with it, which I'll may or may not get to this class. But here's what happens is we want to find out what you're worth to a company. So let's just say that when they hire you, they produce, so let's say their output when they have 100 employees is they produce, let's just say, sorry, that's capital. I'll put capital in here as like 50, okay? And their output when they have 100 employees is they make 2,000 cars. All right? So that would be, they make 2,000 cars with 100 employees, or they mow 2,000 lawns with 100 employees, whatever you want to look, way you want to look at it. Then they want to see what you're worth. So they hire you. You are the 101st person. They keep capital the same. So now, what they're trying to figure out, what a company is trying to figure out is how valuable you are to them. You see? Because if you're valuable, then the output should go up. And if the output goes up, then you're worth hiring. So when you go into a company and you say, okay, you should hire me, then tell them why you should hire them. What's the difference between them with you and them without you? You know, some of you guys in these job fairs coming up, that's what you're supposed to do. You're supposed to sell yourself and say, this is what I'm worth to you. Right? And one of my brothers had this interview one time. He was working for a company. He worked for a company for like 9 years, and they went out of business. And then he worked for another company for about 9 years, and they went out of business. So after not because of him, right? Because he's very good. He's a controller, and controllers are people who control or who do payroll and all the accounting and just all the books basically. And he was kind of the guy who did that at the second company he worked for. And when they went out of business, he went across town to their competitors and say, look, we just went out of business, and I'd like you guys to hire me. Okay? So you guys can visualize this, right? You can see how that could happen. And so the guy who ran the company wasn't real nice. He's like, I'll hire you. I didn't really like that other company, and the guy wasn't cool, owned it, and I'm kind of glad you're out of business. So my brother arranged a lunch with him. So at the lunch, he proceeded to tell the guy all these accounting things that they were doing wrong, and showed the guy how they could save hundreds of thousands of dollars. So what do you think happened? He got the job, right? And he got everything he asked for. Everything he asked for. Asked for, I think, like Fridays off and leaving early because he likes to coach and everything. He got everything he asked for. Okay? Even got a car. Company car. And this is a guy who didn't want to hire him, a week ago, but he sold himself as being somebody who could change the value, right? Who can be productive. And if you can do that, guys, you'll be hired. Right? And now the owner's leaving, and he's actually my brother's actually supposedly he's gonna buy the company like soon, or own the company soon. So it's amazing how you can do this. So what happens is this has to change. This has to go to, let's say, 2010. So what did you just add to that output? 10. And that there, I like that, because what happened is you looked at the change in labor was you, the change in output is 10. It went up by 10 because of you. So the marginal product of labor is just, the marginal product of labor is just the change in output, Q, right? That's my change in Q, over the change in labor. And that's called your marginal product of labor. And when you do that, you have to hold capital constant, right? I'm holding capital constant when I do that. So I can actually determine what you're worth. You can determine what you're worth. And what happens is your productivity should increase as you move along and you get better at a job, right? And you know, if you think about what happened when you first, anybody here, when you first started working, you may not have been very productive, but then after you work for a little while, you get better and better at your job. So your productivity should increase with your time on the job. Okay, so these are just a couple terms that we're going to take forward, and I'm going to show you. We'll do some examples next class. But the point, guys, is this: that when you do this, when you increase the company's output, then you can determine what you're worth to the company. And that's what you're supposed to do when you interview. You're supposed to say, this is what I'm worth to you. This is what I can add to you. I can make you money. And then the companies will be like, oh, okay. And then they'll get hired. So this isn't, we'll complete this next time. But next time, quiz on cost. Make sure you do that. Those sample cost questions, you do as many as you can. And I'll give you a quiz next time we get in. Okay, so have a great day. See you guys. Enjoy.